Alrighty, Mr. Gatekeeper here. Been about 2 weeks since I even done a video. Anyway, we got Mr. Georgia Redneck. Looking like this and looking like that. Oh, GR always feels no pain. Got old GR's 5-pill here. It's a Pirate 5-pill. I've definitely seen a lot of these amps around, and he's got the matching supply right here as well. He said that he was having some issues with the output SWR kind of fluctuating up and down while he was keyed. I got in here pretty quick, found a couple of things that needed to be adjusted, and did quite a few things in here. Just start kind of from the top. I cleaned it up a good bit. I didn't do a pre-video, I should have, but I cleaned it up pretty dang good. It was pretty messy in here. Pretty old amp, you can probably tell. Anyway, one of the first things I noticed, there wasn't a balancing resistor right here, and it always scares me when I see that, because I think that somebody's having an imbalance issue and they're hiding it, and or maybe not use the word hide, they just couldn't keep a resistor right there from blowing up. So they just remove it. They don't know what to do. So the amp was doing power, but we did have an imbalance. Mainly the imbalance was a capacitive imbalance. This 120 right here was reading about 80 picofarad, and we had these two 910s silver dip micas on the output transformers here. One was about 40 or 50 picofarad less than the other. That could be by damage, or that just could be from long-term use, or that just could be from just them being that way off. I'm probably going to say long-term use. I checked all the other caps, they were fine. I went ahead and put you some metal clads on here, as you can see, and that fixed that imbalance right on up. I just threw you a 5-watt resistor on there. I like to do that sometimes with the older amps, just in case there is somewhat of a imbalance, just a tiny slight due to the transistors being not matched. It'll soak it up. But you can tell there has been a blown transistor in this amp before. That's why you see a different 10 ohm, and one of the lots are different on the Toshibas. But anyway, so after that, let's see, I went ahead and retuned the input. It wasn't bad. I just basically, we had these two trimmers on right here. Okay, we had one on the output of the 1-pill section and one on the input. I hate leaving these in and send them back to customers. It's just one of my things. The only amp I will leave them in usually is a tuned circuit transistor, 1-pill or something like that, where sometimes you kind of have to have one in there to fine tune it. But I went ahead and retuned the input, and mic'd in the output of the 1-pill section. Well, technically that's the in-between. Toodles for the guy that originally tuned this joker. He actually tuned this amp with one cap in between, which you can do that. It's a little bit more trickier to do that, but if you know what you're building and you know what it's going to be around, then it makes it easier. Well, this type of design, the capacitance is a little lower anyway. This is more of a high wrap 4-pill design. You got 5 wraps on the input, 4 wraps on the output. That's the thing, man. When you play around with capacitance and wraps, you can. There's more than one way to skin a cat with this. It's an impedance game, like I always say. It's impedance transformation to this way to that way, and you can always play around with different wraps, but you're gonna have to change capacitance. You know, you just kind of pick what you like and roll with it. And I've seen 4-pills do the proper output with all kinds of different wrap configurations. I've seen them do with 2 and 2s. I got a 5-pill over here right now. It's got a tuned circuit input on it. I'm gonna make a little video of it, but it's rolling with 2 and 2, and that thing is kicking butt. But like I said, it's a little bit different of a design. You're having to make up for that lack of wraps with capacitance and such. So he's got a lot of capacitance. So anyway, This was what was on the output for the output tuning capacitor. Wasn't too fond of that, so what I went ahead and did is fine tune this. I threw my trimmer on there and fine tune this, and I'll mic that in. I don't like just taking caps of an amp out of an amp like this and putting it on a capacitance meter and putting whatever this is. I would rather know everything as good as it can be on this bench right here before it leaves. So I went ahead and put your 2 DM19 caps on there. Those won't be failing anytime soon. And let's see here. I don't want to leave nothing out. They got a little preamp over here. Just a little simple little preamp. Okay, here I touched up some solder points on here. I also thickened up some solder down here, which is going to be more of a weak point, as you can see. So I thickened up that and cleaned the board real good. Next little issue was the low switch right here. RF just flows through it through series. The low switch had 2 of these on there, and they were about charred up real well. Had 2 100s to equal a 50 in parallel. So I just went ahead and thrown you, what is that, a 50 blue. Big boys race our young girls, but that's a 56 ohm resistor, 5 watt, so that should do you good. Boxes like this, 5 pills, I'm a kind of more of a fan of a variable, but I mean, this will do the trick. And you're definitely not going to be able to run this on low on this power supply. I'm going to show you here in a minute, but this supply is a little hot. Just hitting it with the bench radio here, which is not a powerful radio at all. I mean, we're driving it at about 3 watts RMS, maybe 16 to 18 peak. It's doing close to a kW already, but the issue is the power supply is not dropping but to about 16 something volts. We'll see. You'll see here in just a minute. So that's a little hot, man. That's a little hot. It appears they got them transformers on the high tap. So, just run at your own risk, bro, is all I can say. That's a little hot. But hey, I've heard people run these Toshibas on 16 volts for 20 years before. But me personally, I try to keep the voltage down if I can't help it. But anyway, we took the power wires out and put some longer ones in. There's the power wires right back there, as you can see. But OGR picked up some wire here, some good Rockford Fosgate wire. I like Rockford wire. It's real close to new concepts that I use. So I went ahead and put that in there, lengthened it out real good for them. I installed these Anderson connectors. My dang had a fuel heater in here, a oil heater, and the dang thing went out on me. I had to pull that out of storage. So I gotta go take that thing back to Walmart. But anyway, so we got the power wire installed, got the Andersons installed for you, bud. Brand new Andersons. I don't think I've left out anything on the amp, I don't believe. Put your strain relief back here, as you can see. Stretched out the the center conductor on these SOs. It's kind of a little loose. Sometimes you got to squeeze them in just a tad bit. I went ahead and did that for you. I don't think I'm really missing anything right here, man. If I do, it may come back to me. So anyway, oh well, go ahead and tell you about I checked this fan out, and there was no resistors or nothing on it to protect it from this supply. That's what's got me kind of wondering. Was this amp ever even hooked up to this power supply? Because if it was, this fan should have blew. I mean, there are fans out there I've seen amongst the years that can handle a lot more voltage. Some of the older fans, this kind of maybe looks like it could be an older fan. I have seen some of them that'll hang in there, you know, with 18 volts or so. This thing is idling at 20 volts over here on the high tap, it appears. So I would think that fan would fry. So that's why I'm kind of curious if it's even been hooked up to it, but I don't know. But to be safe, I went ahead and threw a regulator on there for you. Hadn't used one of them in a while. Lengthen that wire for you to plug into right there and all that good stuff. So it'll work for you on 12 volts in your mobile or the supply. Alright, over to the supply. We went ahead and took the wires out of that as well and lengthened that. And I saw a couple issues I didn't like too much. There was a couple of the connections that were not soldered and they were just crimped. And to me, they kind of looked a tad bit on the loose side. So what I went ahead and did is soldered every single connection. Every single one of these were not soldered on both ends. So I went ahead and soldered them. I tightened down these screws for you real well. These are new lugs I put on there for this power wire. I added ferrite on there for you. Ferrite on there as well. A little bit of inductance there. Let's see here. So you're floating at 20.38 volts. We got a little small bleeder right there. Somebody put a little 2-watt bleeder, man. It'll work. It stays a little warm, but it works. It does the trick. I usually throw like a 250, 280, 290, 300 ohm 5-watt resistor on 100 amp supplies like this. Just a little bleeder to bleed it down. It works though, see? We'll turn this power supply off now. And you'll see it does bleed it down. So there you go, below a volt. So it does work. That bleeder is working. I see they got a fan on here. I always hate seeing electrical tape on stuff in these amps, but sure did grow up using it myself in mobile installations of audio. So anyway, so here we go, man. You got 1,000-watt slug in. I got a 10-watt slug in reverse because you were talking about the reflect, which you know you're not going to see a lot on a perfect load anyway, but it's definitely working well. And so that's a 1,000-watt slug. Like I said, we're on the bench radio. This is PEP, bottom scale. Do 1,000 watts in the corner. Input reflect, 5-watt slug. Do dia, do dia. Great input, especially for having no resistance whatever. As you can see, there is no resistance that comes from the relay to the input. We are in high. Okay, we are in high. So that is a real good tune. All right, just that's your output. Reflect coming back from the dummy load. Do dia, do dia. And that's a 10-watt slug. RMS, like I said, we're just pumping about 3 watts RMS into it. Do dia. So right there, about 300 watts RMS. This thing's kicking ass. I mean, kicking butt. You know, watch my language. What's wrong with me? 20 volts. Do 16.16. A little steep, brother. A little steep. But if I did hit this amplifier with a little bit stronger of a radio, it's probably going to bring that on down to about probably 15.5. So it's really about the radio you're using. That's the only thing about iron cores, man. It's hard to find that perfect sweet spot sometimes, you know. And that's just a thing we dealt with back in the days, and that's why I like putting switches on the high and the medium and low taps to give the users a little bit of control. And these are 50 amp transformers as far as I can see, and it appears the way they've got the primaries hooked up is, to me, it looks like they got the black and the yellow parallel together. Looks like they got the blue cut down to the nubs. I don't even see the blues on these. So I want to say the medium tap is the black, if I remember correctly. I believe that is the medium tap. So if you did want to play around with that, alright, this right here is coming from your switch. This is your primary 110. This is your hot, coming from the switch up here. It's breaking off into these two, into these two. If you want to play around with that, you can undo the yellow on both sides right here. Undo these connections, undo the yellow on both sides. See what voltage you get. On the medium tap, it should be floating somewhere around 17, 18 volts. And right about now it'd probably be dropping around 14.8 somewhere, right around there at 14.8, 15 somewhere. I'm just guessing though, you really don't know till you try it. Every transformer is a little different, it seems. And then you could try that, you know, and of course you could put that on a switch up here up front if you had your double pole double throw switch. And I tell you, that switch up front is too close for comfort to them rectifiers. Look at that. Goodness gracious. See if I can zoom in and show that. See the bottom part of that switch? That thing is close, but it ain't touching. Close. Tight squeeze. Alright, man. Well, that's it, man. This thing's working great. Of course, I could hook a hotter radio up, but god dang, the thing's doing a kilowatt already. 300 bird to hook a hotter radio up, it'd probably doing about 500, 450, 500 bird, probably about 1,300 watts peak. May not go up too much more on the peak side, but she's actually kicking butt for a little old amp like this, man. But glad I could get her done for you, big brother. Say 73 to you, Mr. GR. I feel no pain. The GK, God bless, out here around the northeast end of Georgia. And guess what, friends? It's 2021. I'm still in here getting it done. Got down, got down, got down, got down. 73rd.